What's up, y'all? This is Tom, and this is Like a Math Class. In this video, we're going to continue to build on the idea of limits, and we're going to use that to find out what the slope of a curved line is. We'll talk about a thing called a tangent line, and then we'll look at some specific examples of kind of how to generalize or start generalizing the idea of what happens to find the slope of a curve. Let's get to it. Let's say we've had a straight line like this. Maybe we call this y equals, I don't know, let's say 3x plus 7. I don't know, I'm just making up an equation here. But we knew that this 3 here, that was always the slope, right? The number that was attached to the x was the slope of this line. So if we had some quadratic curve, maybe this quadratic curve is y equals 1/2 x squared. What people naturally thought was that the slope of this curve is going to be 1/2. But that is not the case. That is not the case. Wah, wah. That's not the case because the curve, as you can see, it's continuously changing. So we can't say that it's 1/2 because look here, this thing is going to be you're going to have a different slope here than you would down here. And if I move the line over, the slope right there is going to be different. And even as we go up over this way and we bring it down here, the slope at this spot is going to be changing as well. So as we go around this curve, we're going to get different slopes. And we're going to get different steepnesses of this line. So how do we actually find the slope of a curve? Well, one thing that we can do is we can find the tangent line. And a tangent line is quite simply a straight line that touches but does not cut through any given curve. So for this half circle that we have over here, this is a nice way to demonstrate also that if you've got a line that cuts through like this, this is not considered a tangent line. And this would only be a good approximation to kind of cut through these two things. It's not going to talk about what's happening at any given point as we go around this curve. But as soon as we start moving this line out here, and we could say, at this specific spot right here, the slope, if I use this as one of my points, I could find the slope of this line, which would tell me what the slope of this point is. But as we just talked about over here with our quadratic, as soon as we move this line, maybe we move it up here, and we're talking about the curve now here, right there, that's going to be a different slope than what we just had down here when I had this line down here. Let's get this on here. So these two slopes are very different things. The slope here for this point is going to be very different for the slope at this point. But we need to use this idea of a tangent line in order to find that slope. So what we're going to do is we're going to look back at this graph, and we're going to look at we'll look at just y equals x squared, and we'll try to see if we can generalize kind of what's happening within here to find the slope of a point, let's say right here. So if we were looking for the slope there, we would technically need to get a line that is tangent to this spot. So if we can find that the slope of this dotted line at this one spot, maybe we find this point over here, we could find the slope of this line, which would in turn be the slope at this singular point. Because again, as we go around all of this curve, we're going to have a whole bunch of different slopes, a whole bunch of different steepnesses. So in order for us to find the slope at this spot, what we would have to do is maybe we would start by looking at what is the slope for this line right here. And maybe we say, okay, well, that might be a decent indicator. This line right there might be a decent indicator of this slope, but it's still not going to be quite right. So maybe we take a point right here and we bring it a little bit closer. And so now we look at this one. And I don't know if you can see in there, This is getting better. It's getting closer to this, but this is still just a little bit steeper. And the idea is, as you keep on doing this, as you're getting closer and closer, you're getting a better and better approximation of the slope at this specific spot, but you're not actually finding that until you can get right to this point right here. So let's look at a couple examples and see how we might be able to find the slope at this specific spot. Let's say this is the coordinate of 2, and let's see, if we've got x squared, then this would be 2 squared. So this point we know is going to be 2 and 4, because 2 squared, of course, is 4. So let's look at this point here. We'll call this green point, we'll call it 3, and then 3 squared would be 9, right? So we drop in, if x is 3, then y is going to be 3 squared. So the slope of the green line is going to be, just like any slope equation, is going to be y2 minus y1 over x2 minus x1. All right, so for the green point, we're going to have y2, which will be 9 minus 4 over 3 minus 2. Okay, well, that's going to give us a slope of 5 over 1, or a slope of 5. Okay, so that's a good approximation of this slope, or that's a good calculation of this slope, but it's not telling us what this one is. So maybe we come a little bit closer. Maybe we call this blue point, maybe this is 2.5 and 2.5 squared. So we're going to get a little bit closer to the value of the slope of this line, the black line, but we're not necessarily going to be right on it. So let's try again. So m is equal to 2.5 squared. 2.5 squared is 6.25, and we're going to subtract 4, and that's going to be over 2.5 minus 2. So that's going to give us a value of 4.5. So already we can see, there's going to be a jump as we keep on getting closer. So, or as the points move closer. So maybe we do a point of, let's say, some other point. We'll put a red point in here, and we'll make it really close, and we'll make this point here, this red point, we'll make that be 2.001 and 2.001 squared. So now we're going to find the slope of what this line would be right here. So we're getting closer, and so we're going to be getting closer to the actual slope of the black dotted line. So the slope here is going to be 2.001 squared is 4.004001 minus 4, because that's what our value is right here, over 2.001 minus 2. And when we calculate that, that value is going to be 4.001. So what we're seeing is that as this is going down, as we're going down the curve here and we're bringing our points closer and closer, we're seeing the slope getting closer and closer. And as we continue to stretch this out and maybe make this 2.00001 and get closer and closer, we might have an approximation of what the slope is going to be as this gets even closer. So as these points get closer to that black line, or that black dot right there at the point 2, 4. So it seems to be that the slope of y equals x squared at the point 2, 4 is 4. So, so as we start looking through this, we can try a couple different versions or a couple different points to see if we can see a pattern. So here we're seeing that it's going to be 4. So let's try this at another point and see if we can come up with another generalization of what these values might be. Maybe we could see a pattern in how some of these numbers are starting to come about. So let's find the slope at point 3, 9. And we're going to use the same idea that we did here. So we're going to pick a point really close to 3. So maybe let's use let's use 3.0001, and then since we're talking about the curve y equals x squared, this would be 3.0001 squared. All right, so to find the slope at this spot, we're going to have to take 3.0001 squared. So let's say 3.0001 squared is 9.00060001. 9.00060001 minus 9 over 3.0001 minus 3. Okay, so that gives us a value of 0.00060001 over 0.0001, and that will give us a slope of approximately, actually, no, it's going to give us a slope of, let's do this, 0.00060001 divided by 0.0001, and we have an approximate slope of 6.0001. So 6.0001. All right, so here is a brief summary of the two slopes that we found. So at point 2, 4, we have a slope of 4, and at point 3, 9, we have a slope of 6. So what we'll do is in the next video, we will try to summarize our findings here to see if we can come up with a general pattern of how to find the slope at any given point for any given curve. Talk to you in the next video.